Today we are going to see the next supervised learning algorithm is decision tree. So the name decision itself says that we are going to make some decision based on the attributes. So what is the definition of a decision tree? It's a machine learning, comes under the classification of supervised learning algorithm. It is used for both classification and regression tasks. The structure of the decision tree will be like a flow chart to make the predictions. It works by recursively partitioning the data based on different attributes, ultimately leading to a prediction at the inputs. So we know that how the tree structure will be. The root node will be there. After that, the branches will be going on. Finally, end up with the leaves. So like that only here also we are going to collect the attributes. I mean, we take the example. We will go for dividing the structure with the number of different attributes, and we finally make the decision whether it is yes or no. Right. First, what are the things to be considered in the decision tree? First is the root node. The root node is the starting point of the tree representing the initial decision or attribute to be considered. Next is the sub-branches. We call it as internal nodes. Internal nodes that represents the decision or the test based on the attributes we selected. Each internal node has a branches that lead to the different nodes based on the outcome of the test. So we collect the attributes, we do the test. According to that, the branches will be moving on. So next we come to the leaf node. Leaf node is a terminal node, that is the terminated part that we make a final decision that represents the final prediction or outcome of the decision part. Branches repeat the different outcomes or the possibility of each decision node. This is the about how the decision tree made and how the flowchart has been created and how we are going to make the prediction. This is the flowchart structure. You can see the how the flowchart is. We have root node, then we have a decision node. After that, the decision node has been subdivided into leaf nodes. Again, if there is any sub branches are there, again we make a decision and then we go for further classification. The further branches will be nodes will be created. After the nodes, finally, if there is no more branches or the nodes to be created, we make a end decision that we call it as a leaf node. So this is the structure of how the decision tree has been created. Next, how the decision tree works. What are the content you have to create for making the decision tree? First, we have to start from the root node and we have to split the data based on the best feature. Best feature means we have to find out highest information gain. Highest information gain. And we have to repeat the process recursively until the leaf node is terminated, or we can say until reaching a leaf node, that we call it as an output. Each path from the root to the leaf represents the decision rule. What the track we are going to make from the root node to the leaf node. That path we call it as a what rule we are going to apply to track from the root node to the leaf node is called as a decision rule. So example, we make a game. That game we call it as a tennis, whether we have to play tennis or not. So here we are going to make 4 tables. What are the 4 tables? Outlook. Outlook is nothing but here I'm going to, so whatever may be the outlook. So here we have taken 3 categories. One is sunny, overcast, rain. These are the 3 outlook we have taken, and we are going to take the next category is going to be humidity level, and next wind, and then we go for play tennis. So these are the 4 tables we are going to create. We are collecting the attributes. One under outlook, next attribute is a humidity, third attribute is a wind, and fourth attribute is the playing tennis. Whether to play the tennis under this outlook category and humidity category and wind category. Sunny. First, if you take sunny, humidity level, the first thing represents if the humidity is high and the wind is weak, there is no point of playing tennis. If it is sunny and the humidity is high and wind is strong, if the wind is strong, we can't able to play the tennis. No. Overcast. Overcast, if it is high under humidity level and wind is weak, then we can go for playing tennis. Rain. Humidity is high and the wind is weak. Yes. Rain is normal and the wind is weak and you can go for playing tennis. Rain is normal and the wind is strong. In that case, we can't go for playing tennis. Overcast is normal and the wind is strong and the sky, then we can go for playing tennis. Sunny, if it is humidity level is high and the wind is weak, no. And outlook is sunny and the humidity is normal, wind is weak, we can go for playing tennis. Rain, normal humidity and strong wind, then you can go for playing tennis. So this is how we go for we go for creating a table with the different attributes. For that example, we are creating a flowchart. How the root node is weather we are going to predict it. So in that we have three attributes. We call it as sunny, overcast, rain. That attribute is further subdivided and we are going to have humidity or humidity. If it is sunny, we are going to check the humidity level. If it is high and normal, what decision you are going to make? If it is high, no. If it is normal, yes. Overcast means we can finally we can say that it's a normal. We can go for playing tennis. Only one decision. There's no some subdivisions we need. Subsets are needed. And next is going to be if it is rain, we have to think about what is wind. If it is wind is weak, we can go for playing tennis. If it is strong, we can't go for playing tennis. So this is a flowchart we have created. This is called as decision tree. We made it. So next, what we are going to do it, we are going to see where I can apply. So one thing is I told that one example is a playing tennis. Similarly, I can go for different applications for a decision tree, like medical diagnosis, customer churn, credit risk, email spam, student performance. So these are some examples apart from what the example I have told. Now, how the attribute selections we can make in decision tree. So first we have to understand how the attributes have been chosen. That may be based on information gain. Main thing is information gain. Example is same example. If you take playing tennis is a data state and we are going to apply this in a decision tree algorithm. So first thing is how the information gain can be calculated. So here we are going to apply the process called entropy calculation. The entropy for target. Target is nothing but my playing tennis. So from the table we know we have to find it out how many yes are available, how many no is available for playing tennis. So in that table, we have 6 yes and no is 4. So from that, I'm going to calculate my entropy for to play tennis or not. That is my target. So by applying the entropy formula, we got the approximated value of 0.971. So I have calculated the first process called calculating of entropy to play tennis. Next is we have to split the outlook. Outlook is sunny, overcast, rainy. These are the three outlook we have. So first we are going to take sunny. In that sunny, we have 1 S and 3 no. For that, we are going to apply an entropy and we have to calculate what is the value. So it is around 0.811 for my example. Next, overcast is 2 yes we have, there is no no. So my entropy in this case is 0. Rain is 3 yes we have, 1 no is there. So for that the entropy is 0.811. You can see sunny and rain are having the same entropy level. Next, I'm using all those information. The third step is information gain. Information gain is I'm going to calculate the gain for what? Playing tennis and what is your weather condition is. That is called outlook. That is sunny, overcast and rainy. For this part, two values, I'm going to calculate the gain, the probability of gain. So what we are going to apply, it is total gain is going to be 0.971 minus 4 by 10 into the entropy of your sunny plus 2 by 10 possibility. 4 Is are there. For that, I'm going to do it. And similarly, plus 2 by 10 into 0. That is overcast entropy plus 4 by 10, 0.811. So for three categories, I've calculated with the for to play the tennis or not. Right. So According to that equation, I got my gain value is around 0.322. This is my information gain value. Using that information gain value, we are going to choose an attribute. So using information gain or Gini index to choose what type of attributes. After picking the attribute with the highest gain, repeat the process for each branch helps build a high accurate and interpretable model. So based on this process or based on this information gain or Gini index, I'll tell you about Gini index in the further slide, next slides. So in this case, first we have to find out which attribute is giving a highest gain. After finding out the highest gain, we have to go for repeating the process for sub branches. So when you go for building the sub branches, we can make the decision as clear as possible so that your decision rule is perfectly applied and you can able to find out what is your output, predicted output. So this is the summary of your decision tree. Next is going to be how to calculate the Gini impurity. What this Gini impurity is? It is a measure that how the probability that randomly chosen sample would be incorrectly classified if it was randomly labeled according to the distributions of labels in the data set. So you're going to choose the probability randomly and it would be incorrectly classified if it was randomly labeled. So according to that, you have to make a distribution of labels in the data set. So the Gini formula is for S is the output that is called playing tennis on it is going to be 1 minus summation I varies from 1 to n. How many outlooks? For a probability of PID whole square, where PI is the probability of each class in the set. Yes. So this is the definition of Gini impurity. So using the same sample, here how many samples we have taken? Totally 10 samples. How many S are available? 6 S. How many no? 4. So first step is how to calculate the parent node Gini value for parent node. For parent to node, I'm calculating my Gini value is applying the same formula. I'm getting my the Gini value is 1 minus 6 by 10. 6 is nothing but number of A's. 4 is nothing but my number of loops. So 1 minus 6 by 10 the whole square minus 4 by 10 the whole square, which is around 0.48. Step 2 is Gini after splitting on outlook. So what we are going to do with for Sunny. So for Sunny, it is 4 samples. We have 3 no and 1 yes. And overcast, we have 2 samples. 2 samples we have 2 yes. Rain 4 samples we have it, among that 3 yes and 1 no. So after doing all these calculations, I got for Sunny the Gini value is 0.3 and overcast is 0 and rain is going to be 0.375. So this is how we calculate the Gini value for the attributes we have it. So next step 3 is how the weighted Gini for outlook will be. The weighted Gini outlook Gini value for the outlook is 4 by 10. 4 by 10 is 4 is 0.37. The S value what we calculated for playing tennis, that is for Gini value for yes, that we have substituting it, and I'm going to get a value for 0.3. Similarly for Gini gain, we are going to calculate it. The Gini gain is going to be 0.48 minus 0.3. That so the total value minus the Gini value for the outlook what we got it, and we are going to substitute in this formula, and that is we are finding out the difference between the split data and the total value. So that value will give around 0.18. So the attribute outlook has a Gini gain of 0.18. So this is how we calculate the Gini. So what is the impact of Gini impurity calculation? It is mainly used to measure the node impurity used in the decision tree. Lower, if you have the Gini impurities lower, better will be the attribute for going for splitting. If it works only for binary and multi-class classification problems. So this is how we apply the Gini impurity values for the attributes to make perfect predictions whether we have to go for making a further decision. So this is the about decision tree. Thank you.